Hello there, welcome to part 6 of 3.3 College Algebra, one of the toughest, I would put in the top 2 toughest sections in all of college algebra. We have a polynomial of degree 5, which means we're going to find 5 answers that make this, 5 roots that make this thing equal 0. So notice again that we can solve almost any formula, or we can solve any of them of the form 0 equals and then whatever. Even if you had stuff on both sides of the equation, you could move all that stuff over to one side and then use this process to find all of the answers. So that's pretty powerful if you think about it. We can now solve any equation that's of the form of a polynomial. It might take a while, but we will get the answers. So let's write down all of our possible answers for this. They're all of the roots of this divided by all of the roots of this. Mercifully, all of the roots of this is a 1 right here, so all of our answers are going to be the factors of 54. So we got 1, 2, 3 goes into 54. I don't think 4 goes into that. 5 doesn't. 6 does, though. Does 7? No. 8 doesn't. So that gets us to 9. So now we can just use these to find the other factors. So after 9, it's going to be 3 times 27, I believe. No, that's not right. It's going to be 3 times, what's 54 divided by 3? Is it 18? 18. Excuse me. And then it's going to be 2 times 27. And then 1 times 54. So there's all of our possible answers. Let's do Descartes' rule of signs really quickly. Positive, negative, complex. So we are going to have at least 5 answers. So let's see. 1, 2, 3, 4. 1, 2, 3, 4, 5. Yeah, so that's a 5 right there. 5 potential positive answers. Let's plug in negatives. I get a negative. That stays negative. That becomes negative. That stays negative. That becomes negative. That stays negative. So what that tells me is that we're not going to have a single negative answer. That's nice. We don't need to check any of the negatives. Look at that. That's really nice. So that means we're going to have 5 positive, 0 negative, or 0 complex, because remember, we can't have an odd number of complex answers. But it could be 302, or it could be 104. So once you have a number here, just keep deducting 2 and adding those 2 answers over here to the complex side. So now we just try to find our answers. And I'm going to cheat a little bit to save time. I already know that 3 is one of the answers because I already checked 1 and 2 pretend. So let's try, we checked 1, we checked 2. Neither of those work. So let's try 3. Again, assume I did that. I'm just trying to save some time. We play our game. We get 3, 9, 0, 0, 29, 57. Take away 45. I think it's going to be 12. 36. Wait, I made a mistake. What's 3 times 29? I went going too fast. How about 87? So 87 take away 45 is 42. Oh no, my mistake is back here. Sorry about that. I went going too fast on this. So let's start over. See, even math teachers make mistakes sometimes. But we always check them. So we get a 3 here. No, we get a 1 here. That was my mistake. Bring down the 1. 3 times 1 is 3. Negative 9 plus 3 is negative 6. Multiply those, you get negative 18. That adds up to 11. And then we get 33. Negative 45 plus 33 is negative 12. 3 times negative 12 is negative 36. excuse me, add those together, you get 18. 3 times 18 is 54, and a happy 0. So there's one solution. Now you might check a few of these and discover none of them work, which means that 3 might be an answer again. So let's try 3 again with our new coefficients. Bring down the 1. 3 times 1 is 3. Add those down and you get -3. 3 times -3 is -9. 2, 6, -6, -18, 0. Look at that. I'm even going to give him a smiley. I don't know if it's a him or her, but whoever it is getting a smiley face. So 3 is an answer with multiplicity 2. And in fact, I'm going to try 3 again because I'm feeling lucky. 1, -3, 2, -6, 3, 0, 0, 2, 3 times 2 is 6, 0. Look at that. So 3 was an answer 3 times. So it's 3 multiplicity 2. And look what we have left. We have x squared plus 0x plus 2 is equal to 0. Remember, once you get to a quadratic, you can find the answers by solving it, by factoring, or by using the quadratic formula. So I can actually solve this just by subtracting 2 on both sides. X squared equals -2. Take the square root. X equals positive, negative, the square root of -2, which is I root 2. Okay, then remember that square root of -2 right there is equal to, pull out the I, root 2. So there are our answers. It says find all the complex zeros. So our answers are 3 with multiplicity 3. And I root 2 and -I root 2. Notice these are conjugates of each other. And so if we go back to our Descartes' rule of signs, we ended up with the situation of 3 positive answers and 2 complex answers. That problem is just a beast. It's a very tough one. You can get it with practice, but I'll be honest with you, that problem takes a while. It takes a while. So be persistent, be patient. Let Descartes' rule of signs guide you. Notice we didn't need to check a single negative one because we knew there would be no negatives. And once you get to x squared, you stop doing synthetic division. You can usually find those answers pretty fast. So there are our zeros. Pretty impressive. You made it through section 3.3. I have a feeling this will be the longest section in the class, so congratulations on making it this far. What I'm going to do is, because you watched the video all the way to the end, I want to find out which students made it all the way to the end of this video. So on your notes, I want you to write a special number, and it's just a number I'm going to make up randomly. Well, maybe not that randomly. This is pi to a bunch of decimal places, and so please write this on your paper. 3.141592653588979. That's just approximately equal to pi. I just want you to do that so I know which students actually watched all the way to the end of the video. This, by the way, is probably my favorite number, so it's the number of times the diameter goes around the circumference of a circle. Congratulations on making it to the end of 3.3, and I will see you in 3.4. See you then.